Okay, welcome back, everybody. This is our last video of the day. Thank you for your patience. We're going to look at a simple variation on the molar mass equation, which was derived from the ideal gas law itself. So it's a derivation of a derivation. We talk about gas density, a few things are important, like pressure and volume, and all sorts of things come into play. But if you have two gases that are in similar conditions, so they're at the same pressure, the same temperature, same volume, all of those things, it's the heavier gas, the one that weighs more, that is going to be more dense. Here's an easy way to do a calculation on this as well. We learned about density in one of our very first classes of the whole school year. And we said density is equal to mass divided by volume. So if you take a look at the molar mass equation that we learned about in our last few videos, molar mass was mass times RT over PV. So I want you to look at what we have here. In this equation, right here, we have mass divided by volume, right? Or another way I could write that is molar mass is equal to mass over volume times RT over P, right? Same thing. I'm going to put some parentheses there to make it look nice, but this is essentially the same equation. Well, if mass over volume is density, then we could rewrite this equation and say molar mass equals density times RT over P. And if I wanted to find density by itself, all I'd have to do is multiply both sides by the reciprocal of RT over P. So if I said multiply both sides by P over RT, P over RT, then this side gets rid of RT and P, and we're left with a new equation. And this is what's known as the density equation. Density equals P times M over RT. So let's take a look at a typical equation or a typical problem you might run into with gas density. Sometimes you're going to solve for density, or you might run into a situation like this one where we're given the density and we're given the pressure and we're given the temperature, and all we have to do is find like the molar mass. And so let's take a look at a couple of things we need to do. Our density is fine, but this 23.8 degrees Celsius, we need to change that, right? We need to add 273 to change it to Kelvin. So if I do that on my calculator, 23.8 plus 273 equals 296.8 Kelvin. And I also need to change my pressure from millimeters of mercury into atmospheres. So there are 760 millimeters of mercury in one atmosphere. So on my calculator, 745.5 divided by 760, and I get 0.981 atmospheres. And I'm going to do a little rearrangement of my equation. I really want molar mass, right? So if I take my density equation, D equals PM over RT, I can reverse what I had done previously, and I can just multiply both sides by RT over P, RT over P, and that's going to give me molar mass by itself, right? So here's the version of the equation I'm going to use here. Molar mass equals D times R times T over P. So let's plug in. We were given the density 1.853. R value is the same as always, 0.0821. Temperature is 296.8, and pressure is 0.981 atmospheres. Let's do the math. 1.853 times 0.0821 times 296.8 divided by 0.981, and I get a molar mass of 46.0 grams per mole. Okay, that's really it for new material, not only for today, but for this whole unit. And so I appreciate you watching these videos. I do have an assignment for you to do that's due on Wednesday. And so if you go to the classroom page and you take a look on that classroom page, there's a homework listed at the top. Homework is molar mass and gas density problems. If you open it up, you're going to see that there are 5 different problems. And I don't think they'll take you that long, but I'm giving you until Wednesday to do them. And if you have any questions, you can come visit me in tutorial either today or on Tuesday. And on for all of my students that are going to be missing class on Wednesday, I will be sending out a um, I will be sending out a practice test for you guys to work on over Easter break. And I will also arrange for a tutorial on Monday night of Easter break. I want to remind everybody we do have a test coming up on the Tuesday that we return. And I think if you just do a little bit of work each day, maybe, or maybe a couple days out of the break, you're going to be well prepared. So if I don't see you before then, I'll see you on the Tuesday we come back from our break. Okay? See you soon.